Hello again everyone, welcome back to ptet.chemistry channel. So in this last lecture tutorial, in fact it's a revision tutorial for the year 11 combined science chemistry, we'll be talking about atmospheric chemistry that links in well with the idea of inorganic chemistry as well as chemistry of the periodic table. So let's get started. So sulfur dioxide, which is one sulfur and two oxygen. Di means two, oxide, dioxide, just like carbon dioxide, which is CO2. Sulfur dioxide is SO2, produced when coal is burned in air. Sulfur dioxide causes acid rain. This is a very big fact that you have to know. Write the symbol equation, which of course without them telling you to, you have to balance it. Alright, so I know sulfur plus oxygen will give you SO2, and just like that, this one sulfur and there's one sulfur, there are two oxygen, 1 times 2, they are 1 times 2, so 2 oxygen. This equation will give you the 1 mark, very straightforward. Now they say when the sulfur dioxide dissolve in rainwater, what happened to the pH value of the rainwater? They give the hint there that says that SO2 form acid rain. SO2 form acid rain because the water become acidic. So acidic pH is pH lesser than 7. So pH value will decrease to below 7, or it will drop to below 7 because it will give you acid rain, which is strong acid. Now, two environmental problems. You gotta state something related to the environment caused by the acid rain. So we can think about it is that it can, it can pollute, it can make river water very acidic. You can imagine it can make river water very acidic and therefore kills aquatic plants and also animals. Aquatic meaning the plants and the fishes and whatever. Of course, the other thing that it can do is to the crops. So what it can do is it can make swell. So just now was on the water side, now on the land side, it can make swell very acidic. It can make swell too acidic. Therefore, can destroy or can kill crops. Crops meaning you're growing some crops in agriculture on land, and those can be destroyed as a result of the soil getting too acidic. Actually, you can also think about acid rain destroying or damaging limestone building, but building is not really an environmental problem, so we don't really talk too much about that. Of course, anything else stated in the notes would have been alright. I'm just stating the very obvious things about environmental chemistry here. Next up, name two gases that pollute the atmosphere. For each one, state a source. Source meaning where did it come from? So where from? Okay, so you can be thinking about the first one, which is, well, the same as the previous one. So it will be like sulfur dioxide. And then, of course, the source comes from burning fossil fuels such as coal, i.e. coals that containing sulfur. So there can be a little bit of sulfur contaminants in fossil fuels, and when you burn these fossil fuels in power stations, so from burning fossil fuels in power stations, that is the source of your sulfur dioxide that can cause acid rain. It's pretty similar to whatever they was stated in the previous question. The coal is burned in air in power station. The coal is fossil fuels that contain sulfur. That will give you sulfur dioxide as a contaminant or pollutant in the air. As for your gas number 2, you can be thinking about oxide of nitrogen, such as nitrogen monoxide or nitrogen dioxide. Nitrogen dioxide is Na2. You cannot give NO2. NO2 you cannot give the formula because they want the name. So nitrogen dioxide comes from car combustion engine, from the combustion engine of cars. Because when you have very high temperature, when you combust your fossil fuels in the car engine, what am I talking about? From combustion in car, not really engine actually. I'm thinking about Yeah, I suppose that is true. In car engines, from combustions of fossil fuels in car engine, from combustion of fuels in car engines, and there's enough for the nitrogen in the air to react. So describe an effect, meaning one, and it said describe. It doesn't say state, so it's not state. So we cannot just say something without going into detail about it. Actually, what is common between sulfur dioxide and nitrogen dioxide is both of them can cause acid rain. Okay, so I'll just use sulfur dioxide, but you could have easily used nitrogen dioxide. But I mean, it's the same thing. Okay, that can cause acid rain. So that is not good enough because 3 lines. Yes, it's 1 mark, but 3 lines because they want describe, not stating. All right. So this can make soils too acidic for agriculture, for farming. If you don't like the word agriculture, you can say too acidic for farming. It can kill crops, so can kill or destroy crops. If you don't like to talk about what happened on land, you can talk about what happened to river water. In terms of the river water or seawater becoming too acidic, this can kill aquatic plants, meaning plants that are inside the river or inside the sea. And of course, there will also eventually no plants mean no photosynthesis, and therefore your aquatic animals can also die as well, of course. All right, my point is describe is not stating. If you stop at just can cause acid rain, you might not get the marks because there are 3 lines for just that 1 mark because it's described rather than stating. This is the last page of these tutorials on atmospheric chemistry. So we talked about air pollutants just now. Here is just about the composition of gases in the air. So your air is a mixture. Your air is a mixture definitely because your biggest component is nitrogen gas, that is around 78%. And your second biggest component is oxygen, O2, that's around 21%. And you got other gases which include CO2, argon, etc., etc. Now you have this syringe A, they contain 100 cm3 of air. These are volume of gas. This is copper. The air is passed over the heated copper until no further change in the volume of gas. The apparatus is left to cool to room temperature. State the name. They want the name, not the formula. I've written down the formula as per covalent bonding. In year 9, you know the formula of nitrogen is going to be diatomic N2, where they form triple bond, they form double covalent bond. Year 9 covalent bonding. The name of the gas that make up most of the air is going to be nitrogen. And then the name of the gas that is removed by the copper. Removed by the copper means reacts with the copper. Reacts with the copper. So which gas actually reacts with the copper? It's going to be the oxygen that reacts with the copper, not the nitrogen. So it will be the oxygen. I will give the name for that 1 mark and 1 mark. Now, if the gas that has been removed by the oxygen, that's been removed due to reaction by the copper, so state the final volume of gas. So we know that oxygen is around 21%. So what happened is we started with 100 cm3. So you have 21% of 100 cm3 is 21 cm3. So minus 21 cm3, because out of 100 cm3, 78 cm3 will be nitrogen, 21%, or meaning 21 cm3 out of 100 cm3 is actually oxygen. So do that on your calculator and you will get 79%. Oops, not percent, but cm3, because we are talking about volume. Be very careful about what you are talking about for that 1 mark there. Last question, fossil fuels used for heating. The type of chemical reaction, state the type of chemical reaction. Temperature increase. Temperature increase would mean this is an exothermic reaction because the reaction releases heat. The reaction releases heat, and therefore you will give out heat energy. Is called exothermic type of chemical reaction. The next one, combustion of methane. State the combustion of methane on the number of nitrogen molecules and the number of oxygen molecules. Combustion means in oxygen. if I write a combustion equation, it will be methane plus oxygen. So what I will get later on is carbon dioxide plus water, but that is assuming if complete combustion. But if you read at this question very carefully, they say limited, so not enough oxygen. Not enough oxygen, then you could potentially get carbon monoxide and also water. All right, but that's not the question here. The question is asking what happened to the oxygen. So obviously the number will decrease because the oxygen will still react with the methane. You are still combusting. Whether it's complete or incomplete, the oxygen will still be used up. Therefore, the number of oxygen molecule decreases. The nitrogen does not react. The nitrogen does not react. If the nitrogen does not react, the number of nitrogen molecules, no change. It does not change or no change at all because it does not react. During the combustion of fossil fuels, you get carbon dioxide. What is the test and what is the positive result? So the test is pass the gas through lime water. Use lime water. Pass gas into lime water. Lime water is a solution. So you pass the gas into lime water and you will get a milky. If you don't like the word milky, you can use the word chalky. Precipitate, which is white in color, is produced or is formed, whichever one you like. Just stick with one. Do not have to write both things. Just stick with one thing you like. Just stick with one word you like. Alright, so that's the last page of this huge bundle, this series of lecture tutorials. I started by talking about the periodic table, atomic structure, metals, non-metals, group 1 metals, also known as alkali metals, halogens, the group 7 elements. I then went on to talk about reactivity and extraction of metals, reactivity of halogens, and in this very last tutorial, in these very tutorials, I talk about environmental chemistry, where I briefly touch on oxides of nitrogen, oxides of sulfur, acid rain, as well as composition of air, in terms of reaction, in terms of rusting, in terms of just general concept really. I haven't talked about ammonia and the Haber process, but I mean you have done that in class anyway. So whatever I haven't covered does not mean that they are not in the syllabus. They probably are, so you should always check your syllabus and your specification to make sure that you're not missing out anything at all. If you find my tutorial useful, click the button on the bottom right to subscribe to the ptet.chemistry YouTube channel. It's entirely for free, and yeah, spread the words about the channel and share the channel widely with your friends, chat group, juniors, seniors, whoever else you think might find the channel useful. Thank you for watching, and follow me at ptet.chemistry, that's ptet.chemistry on Facebook, Instagram and Twitter to get connected. I'll see you in the next tutorial video, whenever that may be. If you see me in school, if you wish to get the files offline, just pass me a USB pen drive and I'll be happy to pass the files to you. Alright?